The year 2024 has been a groundbreaking period for Neuralink, Elon Musk's brain implant company. With two successful human trials of their brain-computer interface, Neuralink has rapidly positioned itself at the forefront of what could become one of the most significant technological revolutions in human history. However, this achievement is merely the initial step in Elon Musk's ambitious vision. Everything Neuralink has learned over the past year must now be leveraged to push even further into what feels like science fiction as 2025 approaches. To understand Neuralink's groundbreaking technology, we need to explore the intricate workings of the human brain. Comprising billions of neurons, these tiny yet highly complex cells communicate through electrical signals called action potentials. These signals govern everything from simple movements to memory recall. The challenge for Neuralink lies in translating these natural electrical signals into a language that computers can comprehend. Enter the NUN device, designed as a translator to bridge biology and technology. The NUN implant, about the size of a coin, houses advanced components like a microprocessor, a Bluetooth transmitter, and a rechargeable battery. Its true innovation, however, lies in the ultra-thin wires connected to the device. Each wire, thinner than a human hair, contains multiple electrodes capable of detecting even the faintest neural signals. These wires are implanted directly into the motor cortex, the brain area responsible for movement, using Neuralink's Roan robot. This precision surgical system employs advanced imaging and algorithms to avoid blood vessels and accurately position the threads. Each thread contains 16 electrodes, providing the NUN implant with a total of 24 connection points to monitor neuron activity. Here's how the device works. When you think about moving your hand, neurons in the motor cortex fire specific patterns of electrical signals. The electrodes detect these signals, and the NUN device converts them into digital code. This code is then transmitted wirelessly via Bluetooth to an external device, such as a smartphone or computer. Imagine controlling a computer cursor solely by thinking about moving it. No mouse or physical interaction required. Neuralink has already demonstrated this capability with both animals and humans. In 2021, a monkey famously played Pong using only its mind. Initially, the monkey used a joystick while Neuralink recorded its neural activity. Once the device learned the patterns, the joystick was disconnected and the monkey continued playing purely through thought. For humans, the NUN device is similarly transformative. Inside its biocompatible silicone casing, a tiny computer processes data in real time. Once implanted beneath the scalp, the device is virtually invisible. It features a lithium-ion battery that lasts about 8 hours on a single charge, with wireless charging made simple by placing an inductive coil on the head, akin to charging a smartwatch. This technology isn't limited to computers. By connecting to smartphones, Neuralink allows users to control Bluetooth-enabled devices. Adjusting a thermostat, locking doors, or turning on lights can all be accomplished with a single thought. Neuralink's innovation is revolutionizing human-machine interaction, not just by controlling devices, but by unlocking the brain's full potential. The company's first human trial participant, Nolan Arbau, exemplifies this progress. A 29-year-old former athlete and student at Texas A&M University, Nolan became paralyzed from the shoulders down after a diving accident in 2016. In January 2024, he became the first human to receive the NUN implant. The surgery, performed at the Barrow Neurological Institute in Phoenix, Arizona, took about 30 minutes, with the Roan robot inserting ultra-thin threads into his motor cortex. Post-surgery, Nolan showcased remarkable abilities, such as controlling a computer cursor with his thoughts to play games like chess and Civilization VI. He described the experience as like using the Force, emphasizing how intuitive the technology feels. Nolan dedicates up to 8 hours a day to Neuralink research sessions during weekdays, with personal use extending to 10 hours on weekends. In total, he's logged up to 69 hours per week interacting with the Nun device. Neuralink engineers have confirmed that the current implant's battery life lasts 4 to 5 hours, with a charging time of about 45 minutes. Nolan often keeps an inductive charging coil tucked beneath a beanie, allowing him to recharge independently. Despite these advancements, challenges remain. Shortly after Nolan's implant, approximately 85% of the electrode threads retracted from his brain tissue, disrupting communication between the brain and the device. This issue was attributed to air pockets formed during surgery, which caused the brain to shift, dislodging the electrodes. Neuralink refined its algorithms to optimize the remaining functional electrodes, improving Nolan's performance. By June 2024, Neuralink implanted the Nun device in a second patient, Alex, who also suffered a spinal cord injury. Alex has used the device to control digital tools, design 3D objects with CAD software, and even play fast-pacing games like Counter-Strike, demonstrating its versatility. Neuralink's second surgery revealed significant procedural improvements. While threads for Nolan were inserted at depths of 3.5 mm, the second procedure increased the depth to 8 mm to better anchor the threads within brain tissue, reducing the risk of retraction. These trials mark critical progress toward Neuralink's ultimate goal of restoring independence to individuals with neurological conditions. Looking ahead, Neuralink's ambitions extend beyond restoring mobility. The company's telepathy application enables users to control devices like smartphones and smart home systems using only their thoughts. For individuals with conditions like ALS, this could restore communication abilities by translating neural activity into text or speech. Additionally, Neuralink is developing blindsight, a groundbreaking technology to restore vision by bypassing damaged optic nerves and directly stimulating the visual cortex. In September 2024, the FDA granted blindsight breakthrough device status, expediting its development. These advancements highlight Neuralink's transformative potential. By 2025, the company aims to scale up its human trials, increasing the number of participants and refining its technology further. Long-term, Neuralink envisions replacing traditional devices like smartphones with brain-computer interfaces, fostering seamless integration between human cognition and artificial intelligence. Merging biology and numeric interaction. Merging biology and numeric interaction. Merging biology and numeric and technology to overcome physical limitations and redefine possibilities for the future. The negotiation proves most adroit. Disagreement proves most adroit. This collective collectively created an unprecedented new field. Number 9. A technical term used to describe and promote the benefits of procedural theory.